In this video, we are going to discuss the various factors that are affecting the rate of chemical reactions. The important factors include nature of the reactants, then surface area of the reactant, concentration of the reactant, pressure of the reactants if they are gases, catalyst, intensity of radiation or light, and most important thing, the temperature. Let us discuss these factors one by one. The first one, nature of the reactants. During any chemical reaction, the old bonds that are present in the reactants are broken and new bonds are formed. And it is the energy that is required during these processes that decides the rate of reaction. Lower the bond rearrangements, faster will be the reaction. Ionic reactions in solutions are very fast because during these only rearrangement of ions take place. In solution, ions are already separated and no energy is required for their separation. For example, silver nitrate solution when mixed with sodium chloride solution immediately lead to the formation of AgCl, silver chloride, as a precipitate. It is because in silver nitrate it is in the form Ag plus and NO3 minus. Similarly, in NaCl we have Na plus and Cl minus. These ions will get rearrangement immediately, hence the product is formed very fast, or we consider this as an instantaneous reaction. Reactions involving covalent molecules will be rather slow due to the energy requirement for breaking the bonds. For example, nitrogen combines with hydrogen forming ammonia. During this process, first the bond, there is triple bond between the nitrogen molecule has to be broken, and the bond between hydrogen atoms are broken and new NH bonds are formed. Since energy is involved in the breaking of bonds, this reaction will be rather a slow process. Then rate of reaction in gaseous phase will be faster than that in the liquid phase, which in turn is faster than that in the solid state. It is because in gases molecular motion is rather faster than that is in liquids and solids. Secondly, the factor deciding rate of reaction is the surface area. Greater the surface area of the solids, greater will be the chance of collision between the particles, and hence the reaction will be proceeding faster. So, reactions in which surface area is small will be generally taking place fast. For example, powdered zinc reacts with hydrochloric acid faster than zinc wire with hydrochloric acid. Third factor deciding the rate of reaction is the concentration, and the concentration is having a very important role in deciding the speed of chemical reaction. Increase in concentration will increase the number of molecules present in the reaction mixture. So, the number of collision between the molecules will increase, and this leads to the increase in reaction. So, rate of reaction increases with increase in concentration of the reactants. Next factor is pressure. With increase in pressure, number of collision between the molecules will increase, and hence pressure increases the rate of reaction. Pressure is having effect only on gaseous reactions, reactions involving only solids and liquids has no effect with changes in pressure. Catalyst. A positive catalyst will be increasing the rate of reaction. It provides a new path with lower activation energy for the reaction. One example is in the Haber's process for manufacturing ammonia, spongy iron is used as the catalyst. A negative catalyst will be decreasing the speed of reactions. Negative catalysts are also called inhibitors. Sixth factor which decides the rate of reaction is the intensity of radiation. Light has a very accelerating effect towards the rate of chemical reactions. When intensity of radiation increases, number of photons of light that falls on the reactant also will increase, and this will be leading to lead more number of reactant molecules to undergo chemical change. Hence, speed of reaction will increase with the intensity of radiations. Some reactions take place only in presence of light. Such reactions are called photochemical reactions. Hydrogen and chlorine will not react in dark, but when light falls on it, immediately the reaction takes place, forming hydrogen chloride. One of the most important factors which decide the rate of reaction is temperature. In general, rate of all chemical reactions increases with increase in temperature. Radioactive reactions are not affected by temperature. The temperature increases the average kinetic energy of the reactant molecules. So, according to the Maxwell's distribution diagram, different molecules that are present in the reactants will be having different energy. The graph in blue color, this particular one, is at a temperature. This graph is at a temperature T1, and the area marked here, say this area, represents molecules having minimum energy for reaction to take place. The minimum energy required for any reaction to take place is called as the threshold energy. Only those molecules which possess the threshold energy will take part in the reaction. This area, shaded area, represents the fraction of molecules having threshold energy. The graph that is drawn in red ink, it is at a temperature T2, and the temperature T2 is greater than temperature T1. So here, at a higher temperature, you can see that the fraction of molecule possessing threshold energy increases. That is, this area also, this shaded area plus this one, represents the fraction of molecules having threshold energy. So, with increase in the temperature, number of molecules possessing the threshold energy increases. Hence, rate of reaction increases with increase in temperature. Okay. So, why rate of reaction increases with increase in temperature? When temperature increases, more number of molecules will possess the threshold energy, and hence number of effective collisions will increase. Number of effective collisions will increase, hence rate of reaction increases with increase in temperature. There is a term called temperature coefficient. Temperature coefficient is the ratio of rate constants of a reaction at two different temperatures which differ by 10 degrees Celsius. That is, we have to find out the rate constants at two different temperatures. Say for example, one at 25 degrees Celsius, another at 35 degrees Celsius. 10 degree difference. You find out the K values, and the ratio of these K values at T and T plus 10 is called as the temperature coefficient, and usually has a value between 2 to 3. That is, for every 10 degree increase in temperature, rate is almost getting doubled for every 10 degree, right? So we can generalize a 10 degree increase in temperature will almost double the reaction rate. Now have a look at this table. Say at a 10 degrees Celsius, rate is X. When it increases to 20, the rate becomes 2x. At 30, this will be 4x. 40, 8x. 50 just goes on increasing. So, for every 10 degree increase in temperature. Now, if a reaction rate, temperature increases, say, x into 10 degrees, then rate increase will be 2 power x. X into 10 is the increase in temperature, then increase in rate will be 2 power x. So these are the factors which influence the rate of a chemical reaction.